Okay, good morning, guys. I guess it's 3.1C day two. We're in section 3.1 for a few days here. A lot of very important stuff. This graph interpretation that we've been doing, I can promise you on the AP test, you will have to not necessarily draw a derivative from the original function, but we need to be able to do all this interpretation, such as if f, because right now, Monday, what we did do is we took all this information right here and we said if f is increasing, well, we know f prime is positive somewhere because that tangent line would be positive, meaning the graph is above the x-axis. And if f is decreasing, well, that means f prime's negative or below the x-axis. If I have a flattening, okay, maximum or minimum, but it doesn't have to be a maximum or a minimum. Remember, there were flattenings that kind of come through like this, and I got flat through there, but that wasn't a maximum or a minimum, okay? But whenever I have a flattening, that meant the derivative was zero or on the x-axis, and then we had this bonus little piece of information here. If the original function f had a point of inflection, that actually went and showed a maximum or a minimum on the derivative. So what we're going to do here quick is, whoop, wrong way, sorry, is we're going to, hopefully you had your calculator out and you're going to type in this graph, x cubed plus 2x squared. And what we're going to do is, given the function f, okay, we are going to graph f prime on top of that. And how we typically did that was we made ourselves a little number line, and I'm going to call this number line, it's typically an f prime line for me. And what was really important for us to see is where our function was flat, okay? And we can see we're flat right here. If we actually went in and told our calculator to give us that point, we would see that flat value was about at negative 1.333. And don't forget, in this class on the AP test, an exact value for something is 3 decimal places rounded for us, okay? And we also had, at 0, we were flat, so we knew the derivative would be 0 there, and we knew the derivative would be 0 there. Well, furthermore, we could see to the left of the first flat, our function is increasing, which meant our derivative is positive. And between our flattenings, between our max and min, we were decreasing, which meant our derivative is going to be negative. And then from x equals 0 and on, we increased again, which meant my derivative was positive. Now remember, when I'm going from f of x to f prime of x, increasing or positive means above the x-axis. Decreasing means negative or below the x-axis. And again, increasing from 0 on is positive, meaning above the x-axis. So I know between these flats that I have, okay, I know I'm going to be somewhere above, below, and above the x-axis. So when I drew this, I'm kind of coming down through like so. And that was the graph of f prime of x. Now, don't forget our little bonus piece of information. We can see we have a point of inflection here on f. What did that translate to? Oh, in this case, it translated to a minimum value on f prime, okay? So that's what I mean by the bonus information right here. If f has a point of inflection, f prime has a maximum or a minimum. Well, the second example here, number 10, I'll let you do that one on your own. I'm not going to go through that. And what we're going to do today is we're switching gears, okay? We're going to be talking about, given a graph of f prime, okay? Given a graph of f prime, let's go backwards and find out what the graph of f looks like. So we're totally switching gears today. And you will have to do that. You will have to justify this information. When it says justify your reasoning, I'll explain how you justify. So when we look here at number 1, okay, let's just take a function, and all we know about this, and again, this is going to be f prime of x because we're going f prime back to f. Let's come back and let's say at 1, let's say at 2, I have an f-intercept of f prime, and it's going to be basically a linear function going down. Now, what we're going to do is we want to graph f of x via f prime. And I'm going to do that still by utilizing my f prime line, okay? Because as I look, when I'm looking at the graph of f prime, when I look at graph of f prime, I know here at 2, f prime is 0. And if f prime is 0, that is a potential maximum or minimum on f prime. I really don't know which one it is yet. And then I know because to the left of 2, okay, all those y values are positive. Well, what did that mean for f? That meant f was increasing, right? And to the right of 2, all those y values were negative. Okay, so what does that look to me like? Well, that looks like if f prime's positive, that means f of x, that means it was increasing. Here it had a flattening, and I'm just going to call it a flattening at 0. And then when I was negative, I was decreasing again, okay? So when I'm talking about all this justifying, you will have to read graphs, okay? When is f prime, or when is f increasing via the graph of f prime? Well, it's increasing from negative infinity all the way up to 2. And how do I know that? My justification is f prime is greater than 0. That is the justification the AP board would be looking for. When am I decreasing? Well, it's decreasing from 2 out to infinity. How do I know f is decreasing? Well, if I'm looking at the graph of f prime up here, that is when f prime is less than 0 because it's negative. And when is it flat? Oh, heck, that's when f prime actually equals 0, and that's going to be at x equals 2. Okay, so as I'm looking through here, okay, one thing I do know from my graph of f is at somewhere here at 2. Somewhere here at 2. Okay, and this is why, and I'm going to go back to my original graph here in a minute, this is why it's saying sketch a possible f. A possible f. So somewhere when x is 2, am I going to have a maximum or a minimum? Well, I can come back here to my f prime line, and I can say positive to flattening to negative. That means I'm increasing and then I'm decreasing. Hey, I had a change from positive to negative. That means that's going to be a max at x equals 2. So anywhere when x equals 2, I'm going to make a point, and I know to the left of that, my function is always decreasing, okay? And to the right of that, or I'm sorry, to the left of that, my function is always increasing, so I came up to my flat, and then I went down to my flat. So looking at this, at this thing here, I translate in that to increasing to a flat to decreasing. And as I watch, I'm increasing to flat, and then I decrease. And my bonus piece of information is somewhere here at 2, I do have a maximum. Now, please understand, it's a possible, because if you put your maximum down here and you went like that, you're perfectly fine. If you made yours higher, you could have been like this, and that would have been just fine. It makes no difference. And the reason it doesn't make a difference is if I came back to, not that one, if I came back to this original number 9 that I graphed, I have it in my calculator, okay? So here is my graph of f. I can have my calculator graph f prime for me. All I have to do is go tab, and when I come down here just right between the book and number 9, I have this little menu, and if I grab this guy right here,
what that does is I'm going to type in, please graph me the derivative in terms of x, because all the dependent variables in here are x. And what I'm going to do is, I don't know the equation of it, but I'm just going to say we haven't found our shortcut way to find our derivative, I'm going to say. So I'm going to tell the calculator, please would you find f of 1, because that's the blue graph there, in terms of x. Would you please graph its derivative right here? Okay, so it's going to ask me to graph the derivative. And that's exactly what it's going to do. And watch, when I hit enter, boom, there's my derivative. I can track those zeros, I can track those flattenings straight down. When I'm increasing, I'm positive. When I'm decreasing, I'm negative. When I'm increasing, I'm positive. But when I'm saying a possible value, okay, I can constantly come in here and type a new function in for f. Now, how high or how low do I have to put any maximum or a minimum? Well, just watch. If I shift my graph up, if I took original function, I don't really care, and I added any constant to it, if we remember our graphing stuff, all that's going to do is that's going to vertically shift my function, and it's going to shift my blue graph, but the red one stays right where it is. It doesn't matter what I do. It doesn't matter where I shift that thing up or down. I could say -2, and it shifts it down, but notice my zeros are still transforming right up there. My flattenings go to x-intercepts. Where I'm increasing is still above, where I'm decreasing is below, and where I increase again, I'm above, okay? So that's the thing. That's why it says a possible, because many of these functions, when we actually get into integration, when we take our derivatives back to the functions algebraically, we're going to have this thing called a constant of integration. And when you take the derivative of a constant, it's always 0, and we're going to figure that stuff out. So what I'm going to do is I want to put one on here. We're going to do one more, and then I'm going to ask you to try one on your own. And I'm going to say here at 1, 2, 3. So here at -3, I'm going to be 0. At +1, I'm going to be 0. And I'm going to say somewhere here at -1, I'm going to have a minimum, okay? And my scale kind of stinks here a little bit, but I'm going to draw my graph like so. And we're going to remember this is f prime of x, okay? And we want to sketch f of x. We want to sketch f. Well, how are we going to do that? Well, typically for me is I think of the fundamentals always in math down to the bottom. And what I'm going to do is I'm going to say this is my derivative line again. And I do know here at -3, my derivative is 0. I do know here at +1, my derivative is 0. What do I know? I know to the left of 3, my derivative is positive, okay? Which means my function had to be increasing some way. I know between -3 and 1, my derivative is negative, and then from 1 on out, I'm positive again. So what that communicates to me on f, okay, to go to f now, positive is increasing, 0 must be a flat, this must be a decreasing, this must be some type of flat, to increasing again, okay? And as I look at this, I increase to flat, then I decrease. Oh, looks like that one's going to be a maximum. I had a change from positive to negative. Well, what happens when I have a change from negative to positive? Well, I decrease to flat, and then I increase. Okay, so if I had to graph this, I do know somewhere here at -3, I'm going to have a flat. Somewhere here at 1, I'm going to have a flat. Well, let's just check this out. F prime, when is it increasing? Well, when I look at this little bugger, it's increasing from -infinity to 3, and then from -3, and then from -3 to +1, I'm increasing, and then from +1 to infinity, I'm increasing again, and f is flat at x equals -3 and x equals 1, okay? So here's my flats. Now I know at this -3, looking at my derivative line here, and I have my regular f interpretation written in red above that,
I know somewhere I'm going to have a maximum at number 3, or x equals 3. I'm going to have a minimum at 1. Okay, so somehow I just need to connect these, and I'm going to increase to flat, decrease to flat, and increase again. Okay, now I can check this out too. As I look, my bonus information, which really isn't all that relevant right now, okay, at -1, somewhere in there, I should have a point of inflection because that's where I had a minimum. So I should have had some type of change in concavity. Whether it's perfectly there or not doesn't matter. Now, when you draw yours, you might choose to have both your maximum and minimum above the x-axis, and that's fine. You might go all the way up and then keep one up. That's just fine. Really what we're looking at, and the second one wasn't very good, really what we're looking at is, number 1, did you put your flats where your flats need to be? Are they putting them, are your flats happening here and here? Okay, so let's just do a couple different examples here, and after I draw it on here, I would encourage you to quickly hit pause and see if you can figure it out. Now I'm going to say here at -2, this is my graph f prime. It's a horizontal line. Well, think about this. If my derivative is constantly -2, okay, it's constantly -2, well, that has to be the only thing that has constant slope, because f prime is slope, okay? The only thing that has constant slope is a line. So if I'm coming along here and I look at this thing, I'm saying, hey, where am I flat? Well, I'm never flat. When is my derivative? It's always negative. Okay, this is my derivative line. Everything is there. It's a constant -2 slope. So if I kind of came here, I could say, all right, I'm going to go through the origin. 1, 2. And the derivative of that is my slope. Now, please understand, this line that I drew here, it can be shifted up, it can be shifted down. It really, really doesn't matter, okay? Because here, my derivative, it's still -2. If it's way down here, my derivative is still -2. That's why these are all called possible sketches of f, okay? And now what we're going to do is we're going to do one a little bit different here. And I'm going to say, well, where are we going to say? We're going to say here at 1, I'm going to be 1, 2, I'm going to say -3. But what I do know is this is going to be horizontal. And up here at 1, I'm going to say this side is coming over here. Okay, well, a little bit different. Not a discontinuous derivative. How the heck do I sketch a discontinuous derivative? Well, I think of the fundamentals always, okay? So I'm going to draw my line here. Do I have any flattenings on f in number 4? There are no flattenings, are there? However, I do, here at 1, I do have a derivative that does not exist. And the only way the derivative didn't exist is one of 2 ways. The 2 ways the derivative did not exist on f is if it was not continuous at f, or if I had a sharp point somewhere on f where my left and right derivatives didn't work. Okay? So, and I can see to the left of here, my derivative is always negative, and my derivative is always positive here. Well, what the heck, what does that mean? Well, that means increasing for f, decreasing here, and I just don't have a derivative. No derivative. So I could be discontinuous, or I could be anything else. So what is that going to really show me? I can't really draw humps and bumps in here anywhere, but I do know, here's 1, and I do know I am increasing constantly at -3. So anywhere I could put an open circle. That circle could be closed too, by the way. It really doesn't matter. And if I made a slope of 3, just it's going to be steep, okay? going to be a negative 3. And also, to the right of that, I have a slope of 1. Well, that means rise 1, run 1. This side should be a little bit flatter because it's not as, okay? And just understand, it doesn't matter if this hole is filled. It really doesn't matter if I take this guy and I come down, because my derivative right there still does not exist at 1. Okay? I could drag this above it. My derivative still does not exist at 1. Even if they're connected, my derivative does not exist at 1 because it's a short point. And some people are going to say, no, Mr. Kirk, because it's discontinuous. Well, let me fill that point in. Doesn't really matter. If I fill that point in, now I have a sharp point, and it is still non-differentiable there because the left and right slopes do not meet each other. Okay? So what I'm going to do here is sketch a possible f for number 5. Let's look at this one. This one's going to be a little tougher, okay? So I got negative 1, 2, negative 3. I'm going to have a 0 at negative 3. Remember, this is f prime now. And I'm going to say here at 1, 2, I'm going to have a 0 at 2. And I'm just going to come up here and say at negative 1, I'm going to have a maximum. And what's going to happen on this guy is he's going to come up, he's going to come down and go boink, coming up. Okay? Why don't you hit pause and see if you can draw this function. See if you can draw f down here, except I'm making f red again. And I didn't pause. I hope you paused. And it's a little harder. So let's look at this again. Let's analyze this on my f prime line. It really makes it easier. I know here at negative 3, my derivative is 0. And I know here at 2, my derivative is 0. Okay? And I know to the left of negative 3, my derivatives are negative because I'm below the x-axis. I know between 3 and 2, I'm positive or above the x-axis. And then from 2 out, I'm still positive and above the x-axis. Well, how does that translate to f? Well, how that translates to f is decreasing to flat, increasing to flat, and then still increasing. How would I draw that? Well, here's how I would do it. Here's a negative 3. Here's a 2. What that really looks at me is if I decrease to flat and increase, looks like a minimum at this flat. And then if I'm increasing to flat and then increasing, this looks like this flat is neither maximum nor is it minimum because I increased to increase. I didn't have a change from positive to negative or negative to positive. See, my derivative here is negative to positive. That means I'm decreasing to increasing on f. Well, when I decrease, flat, increase, that's a minimum. This is how we're going to interpret these graphs. Can we draw this little bugger? Well, I think we can. Somewhere at negative 3, I'm going to have a minimum. Somewhere at 2, I'm going to have a flat. So I decrease to flat, increase to flat, and increase again. Okay? So I I decrease to flat, increase to flat, and I increase again. Okay? So, and again, it doesn't matter. You may have had something like this, and that's just fine. You may have kept all of your flats underneath. You may have said, here, and here. Any one of those are fine. Again, what we're really looking for is your graph of f, is it flattening at the correct x values where it's supposed to flatten?
Is it increasing and decreasing between those flats? Is it doing what it's supposed to be doing? Okay, one more here. This is a little tougher one though. Okay, here's one at -1, -2, -3, -4. I'm going to say we have f prime is 0 at -3. It's 0 at 1. And I'm going to say it's going to kind of start up here. And it's going to come here to 1. And then I'm going to say 2. And then I'm going to say 3. But what's going to happen here is this bugger is going to start and it's going to come down and it's going to kind of come up, and I'm going to stop it there, and then I'm going to start it here, okay. Again, that's f prime. That's f prime. This is obviously a piecewise function with a restricted domain on it because I'm starting and stopping, okay? Give it a shot. Think of your fundamentals for most of you that are very confused right now. I know at -3, my derivative is 0. I know at -1, my derivative is 0. I know at 2, my derivative is 0. I know at 1, my derivative does not exist. Okay? Well, what's going out there? From -4 to -3, what am I doing? Well, my derivative's positive. -3 to 1, my derivative's negative. -1 to 1, I'm positive. Here, I have something weird. If my derivative doesn't exist, that means f is either not continuous at 1 or it has a sharp point at 1. Okay? And then between 1 and 2, I'm negative. And then between 2 and 3, I'm positive. Well, interpret this on f now. Increasing, flat, decreasing, flat, increasing, something wonky, increasing, flat, oh, nuts. What did I have there? Okay, those are good. So I had actually decreasing, flat, increasing. And think of it just like that, except something wonky is going on right here. I'm either not continuous, or I have a break in the graph is not continuous, or I have a sharp point. Okay. Again, what does this line mean? Increasing to flat, then decreasing. Decreasing to flat, then increasing. Here it stops. Decreasing to flat, increasing. What does that look like? Well, what does it look like? It looks like here at -3 somewhere, I'm going to have a maximum, doesn't it? So I'm going to choose to put my maximum right here. I'm going to put my -4 here. And then at -1, what do I have? I got a minimum. I can put my minimum down here. Don't make sure, it doesn't matter if you're above or below the x-axis. And then I know right here at 1, something wonky happens, okay? So what am I doing? I'm starting somewhere at 4. Somewhere I'm starting at 4 negative. Okay? So I'm coming down, and I come up to flat, and I come back down. Come back down to flat, and then I'm coming up, and I'm stopping. Okay, that's what the left side looks like. And then from here at 2, I have a flat. Well, I decreased and then increased. Doesn't that mean minimum? A change in my derivative from negative to positive means minimum at x equals 2. Okay, so somewhere I'm going to have a minimum. I don't care where you put it.
I can choose to go off of a sharp point here, decrease, flat, and then increase, and I can be done there, okay? But it does not, just so you know, they do not have to connect, okay? I could drag this guy down, and I could put it right there and still have my minimum down here at 2. It doesn't matter. I could raise it above it, or I can connect it, however you want. Either way, break in the graph, derivative does not exist, or sharp point, derivative does not exist, okay? Whoa, get out of there. Coming up, very last one, 2 examples here. Last thing we want to know, okay? You have to know which direction you're going, okay? Given the graph of f, indicate what values of f prime are positive, negative, or 0, and justify. Okay, because on your quiz tomorrow, you're going to have to know, are you going from f to f prime or f prime to f? Actually, I don't think I have you going f prime to f. I think tomorrow is only f to f prime, but I'm pointing this out. You need to be careful because on the bottom, now that exact same graph is going to be f prime, and we're going to indicate when f is increasing, decreasing, and flattening, okay? It's a big part of the AP test. So how we do this, and we can sketch it, I still love my f prime line, okay? And what does it tell me? It tells me I have a flattening at -2. -2, I'm 0, or a flattening. And at 0, I have another flattening. At 0, I have another flattening, or a 0 slope, because this is the graph of f. This is f of x, not f prime. So a flattening means 0 slope, okay? So a flattening means 0 slope. I know to the left of -2, I know my graph is decreasing to -2, therefore I have negative slope values. Between -2 and 0, I'm increasing, meaning I have positive slope values. From 0 to infinity, I'm decreasing again, meaning negative slope values, okay? I could super easily graph this because I know this is going to be a 0 and this one's going to share a 0. Well, if I'm decreasing, I'm negative. If I'm decreasing, I'm negative. And if I'm increasing, I have to go up and come back down and check it out. It's off a little bit, but that's about where my maximum's going to go, okay? Now, how's my justifying going to be, okay? Well, I know, basically, I'm going to get rid of this a second, okay? Because this is what they're going to do. They want you to look at this. When is f positive? F prime is positive when f is increasing. When is f increasing? From -2 to 0. So this is going to be from -2 to 0. That is the interval on which f is positive. And your justification is because f is increasing. When is f prime? F prime is negative when f is decreasing. Well, when is my function decreasing? My function is decreasing from -infinity to -2 and from 0 to infinity. How do I know f prime is negative there? Oh, that's when f is decreasing. All my tangent lines are negative. When is f prime equal to 0? Or when is it flat? Oh, that is what? That is at x equals 2 and x equals 0. Well, how do I know?
because I have a max slash min on F, or I have a flattening on F, meaning zero slope. Okay? Now, when I switch gears and I go backwards, oh, come on, baby. Come on up. Extend page. Now, here's where I really just need to know. And when I said I really need to know, am I going from F to F prime, or am I going from F prime to F? We really need to know this is the graph of F prime of X. Knowing this is F prime of X, okay? What do we know about F? If I know this is the derivative, when is F increasing? When is F decreasing? When does F have a flattening? Okay, well, all that comes from my interpretation. Okay, I know here in here, okay, I know F has a flattening, okay, at x equals -3 and x equals 0. And I have a flattening in there. How do I know that? I know that because F prime equals 0, justification. F prime equals 0, therefore I will have a flattening on F. Okay? When is F increasing? F is increasing from where? Well, from -infinity up to that -3. And that's the only time F is increasing. And how do I know that? I know that because F prime of X is greater than 0. When F prime is positive, F is increasing. F is decreasing when from -3 to 0 and, really should put my union in there for the and, union with 0 to infinity. My justification, my reasoning why it's decreasing, that's because F prime of X is less than 0 or negative, okay? Because I gotta remember, when I'm looking at these things, all the way back, if I can come all the way back up there, I think, where do I got them? Right here, okay? If F increases, that means F prime's positive or above the x-axis, which means if I'm looking at F prime and it's above the x-axis, F has to be increasing. I need to know, am I going from F to F prime, or am I going from F prime to F for these justifications? Hopefully this makes sense. And if you have questions, look me up on office hours. Have a good day.